we have 5, 8, 1. 1, 5, 8. Split. Then, in case of the split, decide the middle value. What is the middle value in this case?
5.
In this case, it's okay. 5. We don't have to worry about left and right. So, all the left hand side of the middle value going to here. All the right hand side, 8. Then, we have the middle value. Middle value will be promoted. So, this will be 5. Then, don't forget pointer. Actually, there's a pointer. That's it. That's the what when this one is inserted. Next, 7 is inserted. You need to find proper location. Note, 7 is bigger than 5. Okay? You need to, even though you have a space here, you cannot put the 7 here. Always find the leaf node, the terminal node. Why? Because we'd like to be it bottom to up. Always find. Many of the students put the 7 because it's available. No, going to here. Then, is there any space? 7? Yes, we have one space. So 7 and 8. How can you search? If you are searching 1, less than 5 and 1, and the 1 is here, something like that. Then 3 is inserted. 3 is equal or less than 5, and we have space. That's it. Then 12. 12 is bigger than 5, so supposed to be here. Is it? It is full of the node. So what happened? So we need to split into 2. 7, 8, 12. So which one is the middle value?
8.
So this one is the middle value, left hand side, right hand side. So 7, 8, 7, 12, and 8 will be inserted. Is there any space? Yes. So we can insert 8 over here. So check all the child node. Again, equal or less than 5 here, bigger than 5, equal or less than 8 here, bigger than 8 goes to here. And don't forget the data pointer, and this is a pointer, data pointer, data pointer. 12 is done. 9. 9 is bigger than 8. We have space. So 9. 12. And 6. Bigger than 5, less than 8, we have space. So 6, 7. Always, how many levels? 2 levels. Okay, one more time. So 13 is inserted. What happened? We need to find the space. 13. Is there any space? So this is a full, in case of full, split. So 9, 12, 13. So which one is the middle value? 12. Left hand side, right hand side. So we can here one more. So less than middle value 9, 13. Okay. Then the middle value will be promoted. Is there any space?
No.
No. Same thing. We can follow the same step. Okay. How can we do that? 5, 8, 12. Which one is the middle value?
8.
8. So we will take another node. 5, left hand side, right hand side. And what about the middle value? 8. 8 will be promoted. So 8. And check pointer. How many levels?
3.
3. We keep the level of the tree. It's a balanced tree. So, when you access the data 3, this one, how many IO do you need?
3.
First 1, 2, 3,
4.
and 4. Always plus 1. Whenever you are using the index, plus 1. What about 5? What about 6? 1, 2, 3, 4. What about 9? 1, 2, 3, 4. What about 5? 1, 2, 3. What about 8?
2.
1, 2. So, it looks like the balance, but still not completely balanced. It's a bounded. It's a lower, upper bound. It's a 3 in this case, a 4 in this case, but it's equal or less than 4. It's not complete balanced. So, for example, if you travel to the Manhattan for your interview, so transportation, the department said that it will take the maximum 1 hour. You are not sure whether it's 30 minutes, 40 minutes, it's a maximum 1 hour. So it's better than the search tree. We don't know how long it takes. But still not sure whether 30 minutes, I'm in a hurry. So mostly the 50 minutes is okay, but sometimes it can be 1 hour. So database engine does not like such a upper one. Instead, completely balanced. So B3 index is balanced, but not completely balanced. It's kind of upper bound. Still, this one has the different level. So to address that one, there is another in the tree, that is the B plus tree. B plus tree is based on this, but it is the completely balanced. Idea: how can you make the completely balanced B plus tree? Which means whenever you access the data, always the same IO.
Maybe maintaining the copies.
Copies of the problem one is this one, internal load. Leaf node is okay, but internal load. So we put down all internal load, the index key entry to the leaf node. So how can we do that? We will see in the, do we have a time? No. The next class. Idea is, bottom, how can we? Instead of promoting the middle value still in the current node. Then only copy of the index data will be promoted, not pointer. Pointer still exists in the bottom leaf node. Study during over the weekend the B plus tree. On Monday I will quickly explain the B plus tree, then we'll have the quiz for the B tree and the B plus tree. This one is the B plus tree. 99% of the index used in worldwide anywhere is a B plus tree. And some of the simple database use a B3 index. And the others, like the binary tree or binary index, something index, is very rare. So most of them are using B plus tree in relational database. Okay, any other questions? Thank you. And yes, last.
The linear search is similar to brute force.
Yes, linear search is a brute force.
Trying some possibilities.
That's a random. If you know the pointer, it's a random access for the file. But this one is not based on the file stream, it's a block. You need to know the block ID. When you know the block ID, you can directly go, that's a random access. But when you have the many data, so you cannot do that. So at that time, we will consider the indexing search. Okay, thank you, and see you next week, Monday.